Alright, what's up guys? In this video, I'm going to pick up with some calculus here. This is going to be another integration practice video. So we're asked to evaluate the integral t squared times sine of 2t dt. So we clearly know here we have a product of functions, so we're going to have to apply integration by parts. And we know that we're going to have to apply it twice because once we apply integration by parts the first time, it's going to drop the degree of the t down to 1, and then we'll have to do it again. So we will apply integration by parts. And I'll just abbreviate it using IBP''S. And remember, when we get the integration by parts formula from the product rule, if we integrate both sides of it, it'll be the integral of u dv is equal to uv minus the integral of v du. So we need to determine what u is and what dv is. So u in this case, I'm going to pick u to be t squared, and that means that dv is everything else. So dv will be sine of 2t dt. That means that we need du, which is 2t dt, and then to get v, we integrate dv. So that's the antiderivative of sine of 2t dt, and that's negative 1/2 cosine of 2t. You don't need to add a plus c there. We'll add a plus c at the end. And so in problems where, well, you should be doing this for every integral, but in problems where you have to apply integration by parts twice on an integral, please make sure that you're being very, very neat with your work, because you're going to have to go back and get information from the first by parts that you did. So you should be being neat with all your math, but you definitely want to be neat with integrals where you're applying a technique multiple times, because you'll have to go back and get the information. So it looks like we'll get negative 1/2 t squared cosine of 2t. We would essentially get two negatives, thus changing it to a positive, so that would be plus t times cosine of 2t dt. That's the integral that we'll deal with next. So as you can see, much like I said a second ago, we have to apply integration by parts again, because all it's going to do is drop the power. Key integrals to look for where you may have to do it twice are stuff like if I see x squared times e to the x dx, or something like the integral of ln squared of x dx. Those are some examples of where you have to apply integration by parts twice to get the answer. So those are just some examples. There are obviously more examples than this, but those are just some general examples. So we'll do it again. So this time we're not really going to change up the selections at all. Going to kind of pretty much keep them identical. So cosine of 2t dt will be the dv. So du is dt. Yes, the derivative of t is 1, but if you multiply by dt, you'll get dt. So instead of writing 1 dt, you can just write dt. And then v, that's the antiderivative of dv. So that's going to be cosine of 2t dt. That's going to be 1/2 sine of 2t. And again, we'll add a plus c to the end, so you don't have to add it there. Make sure you know how to integrate that. That's just a simple u substitution. So now we go ahead and connect everything together. And so when we do our second integration by parts, remember for the first one we had negative 1/2 t squared cosine of 2t. I'm just attaching everything together. Now, when we do it again, this time it's going to be a positive, so it'll be plus 1/2 t times sine of 2t, and we can basically factor out a constant 1/2, and then that'll just leave us with the integral of sine of 2t dt, which we already know how to integrate. That's going to be negative 1/2 cosine of 2t. So let me just remind you one more time that the integral of sine of 2t dt is negative 1/2 cosine of 2t. It's very important to remember that the derivative of sine is cosine, or derivative of sine of x is cosine of x, but the antiderivative of sine of x, or sine of t in this case, would be negative cosine. So make sure you keep that in mind. So as you can see here, we'll have a negative 1/2. We got a negative 1/2 too here. So that'll be negative 1/2 times negative 1/2, which is positive 1/4. And so all we would have to do is tackle on a positive 1/4 to our cosine of 2t, and then we can add a plus c to the end as our final answer. So we're gonna kind of just go ahead and write our final answer down very quickly. So our final answer for the integral t squared times sine of 2t dt. Our final answer for this integral is going to be a little long, but that doesn't mean that it's wrong just because it's long. So our answer is going to be negative 1/2 t squared cosine of 2t plus a positive 1/2 t sine of 2t. And then it's going to be plus 1/4 cosine of 2t, and don't forget to add an integration constant because you need to, since it's an indefinite integral. And that would be your final answer. So make sure you're being nice and neat with that work so that you can go back and get the stuff that you need to get your answer. All right, so that's going to be your final answer. Let me know if you got any questions about it. I will see y'all next time. Y'all take care.